Okay. Uh, our quest for the remaining 16%, dog. We are at the equations. Sharp. So if you're given an exponential equation, ne? So in these type of question, you're gonna look at this value here, this value. You can see that this value can eliminate. So I'm gonna divide by 4, divide by 4. So the 4 eliminates the 4. And then that also, there's mistakes that you guys do. And you like it a lot. Yo, like this one. When you say maybe you're given 2 over, no, 2x is equal to 2. Then you say 2, this, 2 over 2. It's not equal to 0. Don't say that. 2 over 2 equals 1. Any number over that number, it's 1. Sure. So careful of that error. Sharp. Now you have 25 there. 25 plus 3 equals 1. I know I'm slow, though. I should have changed the 25 into a 5. So it's going to be 5 squared equals 1. So you have 5 exponent. The 2 affects both. So you have 5, 2 exponent x plus 6. This is equal to 1. Careful of this error too, dog. Ne? Most of the time, this is what you do. These are not like what you do, but like what like learners at this grade do, especially dealing with these equations. They'll say 2 plus 3x into y plus 1 is equal to 5. Let's say that's what you're given. So 2 plus this 3x affects the y. It affects also the 3, dog. So you're gonna have 3xy plus 3x. So it affects both, not the only one, right? Not just 3xy plus 1. See, this thing is incorrect. Don't do that mistake. Ever, 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 ever. Please. Sharp. Getting getting to the next one. Getting to the next one. So one can be changed. One can be changed. One can be changed. One can be changed. You know, from the definitions, I have 5 exponent 0 equal to what? Any number to the exponent of 0, it's 1, right? So even 1, I can write 1 in so many ways. It's funny when they say when people tell like each other that they are the ones, and there are so many ones, bruh. Like a over a, it's still a 1. Like 100 exponent 0, it's still a 1, right? You can write 1 in so many ways. Sometimes it's not in like visible. Like here, there's still a 1 here. Still a 1. Check. It's the same thing. Still a 1, dude. So 1 can be written in so many ways. Okay. So I'm gonna say 5 exponent 2x plus 6 is equal to 5 exponent 0. I'm making it 5 because I want to have powers of the same base. I want to have powers of the same base, right? This is power, remember? This is power. The whole thing is called a power. And then this thing here, right? This whole thing, it's called expo. Expo. These are exponents. Do you understand? Yes, then that's the base. So when you say it, you say 5 exponent. You don't say 5 to the power. Stop saying that thing, please. What the hell? Good. Now you have 2x plus 6 is equal to 0. So it's 2x is equal to -6. I divide by 2. This I cancel. So x is equal to a -3. Let's get to the next question. A decimal. This decimal, you can change it. Same with that function of factor on the calculator. No, the S, there's this button that has something like this. Yes. So it's the third to decimal. So to the decimal, can you have a fraction or you can have a fraction? A decimal to fraction. But now you have 1 over 2 exponent x minus 1 is equal to 1 over 4 exponent x. Good. Now, I don't have the same power, the same basis. I do have powers of the same base, but then, no, I do have same powers. Okay, they're not even the same power. They're just powers. Oh, 1 over 2, then x minus 1. I can change this for. Now, there's something that I want to explain here. Because you'll be encountering these type of questions. A lot of them. From now on till you matric. Say, you have 3 exponent 4. Good. So this is going to be 3 exponent 2 exponent 2. But now, if this number it's a 1, like 1 over exponent 2 exponent x, this will be the same as 1 exponent x all over 2 exponent x. Because when you look at this, it's the same thing. If I have 3 exponent, no, 1 exponent 3, this is 3 minus 1. Because the exponent explains that this is 1 times 1 times 1. So the answer is still 1. But when you have 2 exponent 3, it's 2 times 3, no, 2 times 2 times 2, which is equal to 8. Do you see? It changes. It's not the same as 3 exponent 3 again. You have 3 times 3 times 3, which is 27. It's another value, but for 1, it stays the same. So here, I can also have from the laws 1 over 2 exponent x. Do you see? Because of that's what it affects. You remember when you did x over y, then 3. You would write it as x exponent 3 all over y exponent 3, right? Or let's say you had a different value. Let's say you had p exponent 2 all over q exponent 5. Then this is n. So this is going to be the same as p exponent 2n all over q exponent 5n. So it multiplies. See, it multiplies, the n multiplies this and it multiplies that. Doesn't add. Now, getting back here, let's get back. Now I can write this as, can write it as 1 over 2. And this 2 can be here, 2x, right? Because it's like 1 squared over 2 squared, which is equal to x, right? So this is why it's 1 over 2. Then, so it's this thing here, because it's 2x, right? The 2, I factor out the 2, it comes this side. Then it comes 2x. So now the powers have the same base, which is 1 over 2. Can write them as can just equate the exponents. X minus 1 is equal to 2x. Then I have negative x being equal to positive 1. Then I divide by negative 1, right? Because x is going to be equal to negative 1. Good. Now let's get to the second question. Or the third. This one here, always make sure you're changing stuff, 3 exponent 2. Then you have x. You have x plus 3 exponent 2x plus 1 equals 36. Yeah, but I'm just sitting with someone else. I wish they would be in this lesson too. Mm, now you're gonna have with 36, you need to change 36, right? Now, if I change 36, I'm gonna have two factors. It's not like I'm just gonna have a single power as 3. So let me continue and see what happens. The side 2x plus 3 exponent 2x plus 1. Now I have something that is common here. You remember when we were doing uh factorization, using of factorization. So I can just take it out. So if we're still building up, right? So we cannot do this first because of build up. Don't rush the process. Now, 3 exponent 2x is, then this is 1, not 3x. There's nothing there. I have 1 plus. I'm taking out this one. So I'm just going to be remaining with 3 exponent 1, 36. So 3 exponent 2x into 4 equals to 36. And I divide by 4. So 3 exponent 2x is equal to, if I divide 36 by 4, I'm going to get 9. So 3 exponent 2x is equals to 3 squared. So if I solve for x, I'm going to get that x is equal to 1, right? X. So let me not skip step. So 2x equals 2, then x is equal to negative 1. No, sorry, positive 1. Now, here's an activity for you. Do all these things here.